Hello, all the prestigious personalities and prodigious people. This is me, Aryan Kumar, and today we are going to study another crucial topic that simply emphasizes all about mass and mass relationship. And if you are following throughout the series of this chapter, that can be stoichiometry, or even if you are trying to cover the basics of chemistry, you have found the best video available, maybe for your board or topic. Anyway. Uh, our today's topic is mass and mass relationship. First of all, what is definition? I won't bore you. That's why I have a perfect definition for you. That simply says that if there's a unknown value, unknown mass, basically. Now, of course, this person I'm drawing as an example carries any particular mass. Now, if any particular mass is unknown in the question or equation, okay, then you have to go through the mass of the given reactant and product, that is called our balanced chemical equation. Okay, I can just write it as B and dot eq, that is balanced chemical and equation. And after looking at that, you have to check the given data of your question. Okay, question. Okay. Now this is the loop that we try to follow whenever we are trying to solve any mass and mass relationship. Okay, and of course, if there's any question that includes the number of moles of any element, then you will convert that number of moles into its um, like granular value, or you can say into its mass from by using um, moles formula, that is moles equals to given mass upon molar mass. You will simply try to for suppose that is a element known as hydrogen, and I don't have my given mass because that isn't present in the element, of course, and I have 8 moles of air, and I have to find its gram atomic unit. That will be multiplying by 1, and it would again give me 8. Basically, that would be converted from 8 moles to 8 gram of the element's mass. That's how we will calculate the mass by mole, like convert the mole to the mass. If we have any type of moles or any type of equation that simply says that you have to first calculate the moles, then find the mass. Anyways, I have a lot of examples, but before example, I have a definition for you that simply says like the mass and mass relationship. In this, we have to determine the unknown mass of reactant and product, as I said, the example as a person, and from the given mass of any substance, substance equals to the elements that are given in the equation. Okay, and that are like the values are taken from its chemical equation and quotients. That is a simple definition that I would like to elaborate at this point. Now let us just take an example at this point. First, suppose I'm having a example as, consider this example. Okay, let me just switch this up or write it here by erasing it. Okay, I'll quickly erase it for you. Okay, perfect. We are done with erasing this also. Okay, now just suppose a question that says find the mass. Okay, find the mass, okay, of this particular balanced chemical equation. Now I would like to target three major rules, but at first I would like to write this for a better understanding. Okay, now N2 plus 3H2 is making 2 moles of what? NH3, and NH3 is commonly known as what? You already know that, that is ammonia. Perfect. Now you can just simply try to understand this, but before understanding, I would like to see this balanced equation if it is balanced. Okay, now if it isn't like balanced at a point, at any point, then the first step you should follow is try to balance it. Now at majority of the cases, you don't have to measure it or try to balance it because it is already balanced in a lot of ways. But if there's something like at very basic points such as c plus o, that gives me what c o uh, 2. Now of course you would try to uh, balance this by adding a coefficient, and that is how you try to balance it. Okay, now let's just try to solve this equation. First of all, you will see the first thing would be to see if it is balanced or not. The second thing is to check the number of given substances in our equation. Okay, so I can simply say given data of equation, and that will be equals to something around by this equation that we are trying to find. Now let's just suppose um, an equation that says uh, like I have to find mass. Okay, mass of it, mass of NH3 when it is produced. Okay, so let me just try to solve it. Now of course I have to try to find this by using NH2. When NH2, when an NH3 is formed, I have to see how much N2 is trying to be utilized in this equation. Now, of course, the first thing I would like to do is find the molar mass of N2. Okay, now how to find the molar mass? Multiply its number with the value or coefficient that is right there. 2 multiply by 14, and that would be, I would like to say 28, I believe. Yep, and as it triggers the second thing as NH3, and NH3 simply gives me 34. And the question asks me how much gram of NH3 it produces. So that gram would be my X, that 34 would be my its molar mass, and the thing that is being produced, that is 28 uh, like grams of N2. And if I say uh, the given mass, okay, the given mass is 56 in the equation. Okay, for N2 the given mass is 56 in the equation. Then I can simply do a thing, not rationalize this, try to create ratios out of it. Now how will I do that? Simply just try to cross multiply each equation. Now this would be 28x, okay, equals to 34 multiplied by 56. That probably gives me some number. Okay, probably gives me some number, and that number will be divided by 28, and that's how you find your mass of NH3 when it is produced twice in a equation. And I haven't written any type of question right here because I believe doing it with the equation is more efficient way. Anyways, you can consider to write a question as well by just after understanding this. Now you will just multiply these both equations. Let us just do that. 34 multiplied by 56. Okay, 34 multiplied by, sorry, 34 multiplied by 56, that would give me 1904. Now how to do that? I will just put this right here, 1904 divided by what? 28. And if I divide that by 28, let's just do what it is. If I divide this by 28, I would get probably 68 as my answer. And that is how you try to solve any critical type of equation question. And these were the three rules you majorly apply in any type of question, not only about this particular pneumonia, or not pneumonia, sorry, there's a name of a disease, ammonia type of questions, or any other element that can be anything like maybe iron, maybe um, copper, maybe carbon dioxide. That depends on the variety of the elements. Of course, we will use elements as our molar masses, then we will calculate it. You can just revise this video if you haven't understood the concept. That's it from my side. Thank you.